I suspect by this point that you may be a little bit confused on hypothesis testing. Through the years that I've taught this course, hypothesis testing tends to be one of the more difficult concepts, but I promise you, you will figure it out because it stays with us for the rest of the semester. I honestly think this video will be the one where it all starts to click as we work through these 7 problems. So what you're going to want open is the one sample hypothesis testing classwork. And I'm going to be going through this and typing in answers as we go through this video, so I'll also post this key. And then you're also going to want Minitab open. It can be just a blank worksheet. It doesn't matter because we don't have a data file for this classwork. All right, let's get started on these questions. And again, what you may want to do is try to work the questions on your own by pausing the video and then come back and listen to the solutions to see if you got it right. All right, number 1. A consumer group claims that the mean annual coffee consumption by a person in the U.S. is 23.2 gallons. A random sample of 90 people in the U.S. has a mean annual coffee consumption of 21.6 gallons. Assume the population standard deviation is 4.8 gallons. At alpha equals 0.05, can you reject the claim? Okay, so first of all, part A says, write the null and alternative hypotheses and state the claim. All right, so we need the null and alternative. The null and alternative is going to be based on, let's see here, is going to be based on what the claim is. So we read in this first sentence that a consumer group claims that the mean annual coffee consumption by a person is 23.2 gallons. And so we read that as mu equals 23.2. All right, so because it is equals, it is stating equality, that's going to go into the null. All right, so we have our null is equal to mu 23.2, and that is the claim because that is what we're reading. And then the alternative is going to be mu, and we've got not equal, so I'm going to have to add in a symbol here of not equal. Let's add in not equal. (23.2). Okay. All right, so now these first 2 problems in the classwork, I want us just to practice together interpreting a type 1 and type 2 error. Now again, these are theoretical, they are hypothetical, so we just want to interpret within the context of what a type 1 and type 2 error means. All right, so I'm just going to put in parentheses here with a type 1 error that it is when we reject the null but the null is true. All right, so that's what a type 1 error means. Now we want to interpret for this problem what that means. So if we reject the null, that means we're concluding the alternative. So we conclude the alternative, which says we conclude the mean is not 23.2 gallons. All right. But the null is true. So we conclude the mean is not 23.2 gallons when in fact it is 23.2 gallons. Okay, so that's all there is to it. So again, here rejecting the null means concluding the alternative. So we conclude the alternative, but the null is actually what is true. Okay. All right, so again, what would a type 2 error look like for this problem? Well, this is where we conclude the null, but the alternative is true. Okay, so it's kind of the opposite of what we just did for a type 1 error. All right, so now we conclude the null. So we conclude the mean is 23.2 gallons when in fact it is not 23.2 gallons. Okay, so again, just a little bit of practice with type 1 and type 2 errors. All right, so I want to go to Minitab and I want to find the p-value, but when we go to Minitab under one sample, we have to choose between t, z, and proportion. So let's go back to this question. Question 1, is this going to be z, t, or proportion? And the key is in this sentence right here. Assume the population standard deviation is 4.8 gallons. Because we're given the population standard deviation, this is going to be a z one sample test. So we go into one sample z. All right. We do not have data from a data file, so we have summarized data. All right. And we take a look at our problem here, and our sample size is 90. Our sample mean is 21.6. Our known standard deviation is 4.8. All right, we do want to perform a hypothesis test, so we check the box. All right, what is the hypothesized mean? So the hypothesized mean is that claimed amount that you wrote in the null and alternative. So that is the 23.2. All right, and then we need to go under options, and we need to specify the alternative hypothesis. So do we have a two-tailed test, a left-tailed test, or a right-tailed test? And we can look at our alternative here that reads mu not equal to 23.2, so we can leave it on the default of not equal to. All right, we can ignore the confidence level because we're not performing a confidence interval. All right, so again, you can ignore the confidence level. Simply press OK. All right, and right here under test is the result of our one sample hypothesis test. We see that Minitab gives us our null and alternative as we wrote them in part A. And then we get a p-value of 0.0016. So our p-value is 0.0016. All right, and we want to make a decision. All right, since 0.0016 is less than our alpha of 0.05, we reject the null hypothesis. All right, so when the p-value is less than alpha, we reject the null. When the p-value is greater than alpha, we fail to reject the null. All right, so again here, because the p-value is less than alpha, we reject the null hypothesis. All right, now we want to interpret what this means for the problem. All right, so if we reject the null, that means we are concluding the alternative hypothesis. So there is enough evidence to reject the claim that the mean coffee consumption is 23.2 gallons. Okay, so there's enough evidence to reject the claim, all right, because we are rejecting the null and the claim is the null. All right, let's go into number 2. The Western blot assay is a blood test for the presence of HIV. It has been found that this test sometimes gives false positives for HIV. A medical researcher claims that the rate of false positives is 2%. A recent study of 300 randomly selected U.S. blood donors who do not have HIV found that 3 received a false positive test result. At alpha equals 0.05, can you reject the researcher's claim? All right, so notice, all right, at the get-go that this is a proportion one sample hypothesis test. All right, we do not read anything about mean. We do not read anything about standard deviation. We are given a rate of false positives, a claimed rate, all right? And we are given how many out of a sample actually display the false positive. All right, so, all right, we've got our null here then is not mu, but p for proportion equals, and we can either say 2% or we can say 0.02. Okay, and that is the claim that we are reading in the problem. And then our alternative is p, and I'm just going to go up here and copy our not equal to, 2%, or 0.02. Okay. All right, so one more time here, let's go through interpreting the hypothetical type 1 or type 2 error that could be made. All right, so again, type 1 error is reject the null, but the null is true. Okay, so if we reject the null, that means we conclude the alternative. All right, so I'm just going to say one more time, conclude HA, but HO is true. All right, so we want to write that in terms of the problem. So we conclude the rate of false positives is not 2% when in fact it is 2%. Okay, so again, we conclude the alternative not 2% when in fact the null is true, which says it is 2%. Okay, type 2 error is going to be the opposite. So now we conclude the null, but the alternative is true. So now we conclude the rate of false positives is 2% when in fact it is not 2%. Okay, so again, here concluding the null of 2% when in fact the alternative is true, which means not 2%. All right, so now we want to actually go over to Minitab and try to find the p-value for this problem. Okay, so again, this is a proportion one sample test. All right, so we go into proportion. We have summarized data. All right, so again, number of events. This would be the number of people in our sample that actually display the false positive. So that is our 3 people. Okay, and how many people are in the sample? That is the 300. We do want to perform a hypothesis test. And the hypothesized proportion, now we actually have to convert to the decimal and type in 0.02. All right, we go under options. And we need to specify our alternative, which here is not equal to. We can ignore confidence level. And because it is a proportion, we have to change the method to normal approximation. And we say, okay. All right, and we see that we get a p-value. Let me move Minitab over just a little bit. All right, we get a p-value of 0.2160. All right, and so what decision are we going to make based on this p-value? We say since 0.2160 is greater than our alpha of 0.05, we fail to reject the null hypothesis. Okay, so just to kind of beat it in your head, remember that there's only 2 decisions. There is reject the null and there is fail to reject the null. Never ever do we say accept the alternative. Okay, so here, because the p-value is greater than alpha, we fail to reject the null hypothesis. All right, so what does it mean to fail to reject the null here, which is the claim? All right, it means there is not enough evidence to reject the claim that the rate of false positives is 2%. Okay, so because we fail to reject, we have to say there is not enough evidence. Okay, all right, moving right along. Number 3. A researcher claims that the mean cost of raising a child by families in rural areas is $11,060. In a random sample of families in rural areas, the mean cost of raising a child is $10,920. The sample consists of 800 children. Assume the population standard deviation is 1,561 and alpha equals 1%. Can you reject the claim? All right. So here we are reading about mean and standard deviation, so we're going to have a null and alternative hypothesis worded around mu. All right, so let's start thinking about what this null is going to be. All right, so we've got mu mu what? What is the claim here? So a researcher claims the mean cost of raising a child by families in rural areas is $11,060. All right, so we read that as mu equals $11,060, and that is the claim. And that gives us an alternative of mu not equal to $11,060. All right. Is this going to be Z or T? And we go back to the problem and we read, all right, right here, assume the population standard deviation is. So because we get that population standard deviation, that means this is going to be a Z test. So we go into one sample Z. We have summarized data. Our sample size is 800 children. The sample mean is 10,920. The known standard deviation is 1561. We do want to perform a hypothesis test, and that claimed amount is 11,060. We go under options, and our alternative stays as the default, as not equal to, as we see here in part A. We can ignore the confidence level, and we say okay. And again, we notice that our null and alternative here from Minitab matches exactly what we typed in part A, and we get our p-value of 0.0112. All right, so our p-value is 0.0112. And to make a decision, we want to think about how this compares to alpha. Now notice here alpha is 1%. All right, so I gave you a smaller alpha. So since 0.0112 is greater than 0.01, okay, because 1.12% is greater than 1%. So since the p-value is greater than alpha, we fail to reject the null. All right, so what does this mean in terms of the problem? There is not enough evidence to reject the claim that the mean cost of raising a child is $11,060. Okay. Number 4. A Greenville city planner claims that the mean speed of traffic southbound along I-85 during morning peak hours is less than 50 miles per hour. In a random sample of 45 motor vehicles traveling southbound on I-85 during morning peak hours, the mean speed's 51 miles per hour. Assume the population standard deviation is 5 miles per hour. At alpha equals 5%, is there enough evidence to support the city planner's claim? All right, so we finally get into a one sample problem. All right, and let's see here. We got our null and alternative set up here. So what do we read in this problem? We read that the mean speed, so mu, is less than 50. All right, so we can think about what that's going to look like mathematically. That is a strict inequality, so what we're reading there is the alternative. So mu is less than 50, and that's the claim that we are reading. So that means that the null is mu greater than or equal to, so I'm going to need a symbol again. Oops, here we go. So mu greater than or equal to 50. All right, is this going to be Z or T? And again, we get this sentence in here about the population standard deviation. So this is going to be Z. All right, we have summarized data. All right, our sample size is 45. The sample mean is 51. The known standard deviation is 5. We want to perform a hypothesis test, and the hypothesized mean is 50. And now when we go under options, we do have to specify the alternative. Our alternative reads mu less than 50. So we want to choose the less than hypothesized value. And we say okay. All right, and let's just take a second to look at how Minitab writes this. What happens here is we write the null and alternative as complements of one another. So we write our null as greater than or equal to. Minitab just simply puts an equal to mark, because what happens in the hypothesis test is that we go in assuming equality at 50. All right, that's what the null is saying. We're assuming equality, but we're allowing it to be greater than 50, and we're specifically just testing less than 50. All right, so just know that when you see this in Minitab, it is the same thing as what we have written over here in Part A, okay? As far as quizzes and tests go, I prefer you to write it as I'm doing here in Part A. I prefer you to write it as the complement, the mathematical complement of one another. All right, so what is our p-value? I moved it. All right, so our p-value is 0.9101. All right, and so since 0.9101 is clearly greater than 5%, we fail to reject the null. All right, so what does that mean here now that our alternative is the claim? All right, so what we say is there is not enough evidence to support the claim that the mean speed on I-85 is less than 50 miles per hour. Okay, so notice, let's just take a second to take a look here. And I have given you this information in a matrix in Blackboard, all right? But when our claim is the null, as it was in the first 3 problems, we either say there is enough evidence to reject the claim, or we say there is not enough evidence to reject the claim. When the alternative becomes the claim, the language changes to there is or is not enough evidence to support the claim. And again, this is one of those things, as you guys practice it, it just becomes much more common sense. I think right here at the beginning, it's a little bit confusing, but again, I promise you it gets better. All right, number 5. A restaurant association says the typical household in the U.S. spends a mean amount of $2,628 per year on food away from home. You are a consumer reporter for a national publication and want to test this claim. A random sample of 34 U.S. households has a mean amount spent on food away from home of $2,694 and a standard deviation of 322. At alpha equals 5%, can you reject the association's claim? All right, so let's get our null and alternative. All right, so we read here that the mean is 2628. So we're going to say for our null, mu equals 2628. All right, and again, that's the claim because that's what we're reading. And our alternative is mu. Now I'm going to go back up here and copy our not equal to sign. All right, so not equal to 2628. All right, so we want to go over to Minitab, and we know we're reading mean and we're reading standard deviation, so we know it's going to be Z or T. The question is, which one is it going to be? And notice now we get this entire sentence right here, all right, that describes the sample of 34 U.S. households. And in this sample of 34, we get a mean and standard deviation. All right, so this is a sample standard deviation, so that means it is going to be T. All right, so we go over to one sample T. We have summarized data. Our sample size is 34. Our sample mean is 2694. Our sample standard deviation is 322. We want to perform a hypothesis test, and that claimed amount is 2628. We go under options, and we want to run an alternative of not equal to, so we can leave it on the default. And once again, we can ignore confidence level. We say okay, and we notice our null and alternative here in Minitab matches what we have typed in Part A, and we get a p-value of 0.2405. All right, since 0.2405 is greater than 0.05, we fail to reject the null. All right, and since we fail to reject the null, there is not enough evidence to reject, all right, to reject the claim that, oops, helps if you spell words right. All right, the claim that the mean amount spent on food outside the house each year is $2,628. All right, so there's not enough evidence to reject that claim. All right, number 6. A polling agency reports that over 60% of U.S. adults think that the federal government's bank bailouts were bad for the U.S. In a random sample of 298 U.S. adults, 167 said that the federal government's bank bailouts were bad for the U.S. At alpha equals 1%, can you support the agency's claim? All right, so again, we see we are given a claimed percent. We do not read anything about mean and standard deviation. So we know that we are going to have a proportion test here. And so our null would be, let's see, a polling agency reports that over 60%. All right, so how would we write over 60%? We would write P greater than 60%. All right, so that would be our alternative. Oops, and let me say that that is the claim because that's what we are reading. And so that means that our null would be P, and I'm going to have to put in a symbol here of less than or equal to 60%. Okay, so again, this is a proportion test. We have summarized data. All right, so what are our numbers here? We have 167 who say they're bad. Out of 298, we want to perform a hypothesis test on 0.60. And under options, we need to change our alternative to greater than, and we need to change our method to normal approximation. Okay, again, we can ignore confidence level. All right, and let's take a look at what our test says. So again, because it's one-tailed, we see equals in the null only because the software goes in assuming equality at 60%. All right, the important thing is that our alternative exactly matches what we have in part A. And we see a p-value of 0.9185. All right, so since 0.9185 is clearly greater than 0.01, all right, we fail to reject the null. All right, so what does it mean to fail to reject the null? There is not enough evidence to support the claim that over 60% of U.S. adults think the bank bailouts were bad. Okay. So again, we use the support language because the claim here is the alternative. All right, and we fail to reject the null, so there's not enough evidence to support the claim. And what does that claim say? That over 60% of adults think the bailouts were bad. All right, last one, number 7. Okay, a fitness magazine claims that the mean cost of a yoga session is no more than $14. You work for a consumer advocacy group and are asked to test this claim. You find that a random sample of 32 yoga sessions has a mean cost of $15.59 and a standard deviation of $2.60. At alpha equals 0.01, can you reject the magazine's claim? All right, so what do we read in the problem? We read that the mean is no more than 14. Okay, so how do we write that? We write that as mu less than or equal to, no more than, 14. That's the claim because that's what we're reading. All right, which means the alternative is mu greater than 14. All right, so is this going to be a Z or T test? And again, notice here that we have a sentence describing the sample that includes the sample mean and the sample standard deviation. So this is going to be T. All right, we have summarized data. The sample size is 32. The sample mean is 1559. The sample standard deviation is 260. We want to perform a hypothesis test on $14. Under options, we need to specify our alternative as greater than, and we say OK. All right, and so notice that we get a p-value of 0.0008. All right, and since 0.0008 is clearly less than 0.01, we reject the null hypothesis. All right, so what does that mean for the problem? All right, there is enough evidence to reject the claim that the mean cost of yoga is $14 no more than $14 per session. All right. As you work through the homework, if you have any questions whatsoever, get in touch with me before you take the quiz. All right. And then again, as a reminder, you get 2 attempts on the quiz. If the first one does not go well, reach out to me on the questions that you missed so we can go over them so you don't repeat the mistakes on the second attempt.